Welcome, everybody, to the Unnamed Reverse Engineering Podcast. I'm Jen Castillo. With me, as always, is Alvaro.
Hello. Awkward pause. All right.
Alvaro, you know when you wave at the microphone, it can't hear you. But anyway, the reason why we're here today is because we have a special guest, Laura Abbott. Welcome.
Hi, thanks for having me here.
And why don't you tell us a little bit about yourself, like your elevator pitch, as they say.
My elevator pitch. Oh, I haven't had a chance to do that in a while just because I haven't met too many people in so while, but let's see if I remember how to do this. So, hi, I'm Laura. I'm a software developer currently at Oxide Computer. My background was previously doing a lot of Linux kernel development, doing things related to memory management and Android. I was a kernel maintainer for the Fedora distribution. These days at Oxide, I am working on Hubris, an operating system in Rust for microcontrollers.
Whoa. So you're part of the movement where we're confident that we can move past C++.
I think I'm excited to see Rust as the future. I've seen and have known about Rust for a very long time, and I think it's been a question about when exactly it's ready for prime time. And I think Rust provides a promising future.
That's
not sure if I'm ready to say rewrite everything in Rust, but it's good to see change incrementally.
Agreed. Honestly, if I could just like get rid of like the whole modern C++ thing and just like go to Rust, I guess.
Yeah, I mostly do C, so Rust is probably more easier change than if I had a huge C++ project.
I would probably agree with you because I have to say, as a primarily C writer, C++ makes no damn sense. But that's not why we're here to bash C++. Although I'm sure we could do it.
That's easy.
That's an easy hour right there. So, Laura, you work at Oxide, and it looks like while you were there, well, let's take this back one more. You've kind of stumbled into reverse engineering along the way. Tell us how you ended up doing that.
I did. It's kind of been an interesting experience, is that when I introduce myself, I try and say I'm not actually a security researcher, despite what it seems like I've been doing recently. So backing up a little bit about what Oxide is doing, I swear this isn't going to be a pitch for Oxide, but just to give some context.
That's okay.
Oxide is building a server from the ground up, really rethinking the design. And part of that is rethinking how security works. And one of the aspects I've been working on and thinking about is building a root of trust. And what this is designed to do is be able to give a confident answer about what software is actually running on your system, which includes everything from the firmware all the way up through the host software, because it turns out there are a lot of pieces of software that will run on a rack besides just the host operating system, like what you usually think of as Linux or something like that.
And I guess I should mention that you work with one of our past guests who introduced us, Rick Alther, for folks who want to go listen to other fun episodes.
One of our more popular episodes, if we're honest.
It was more car hacking than servers, but he's a great engineer.
Yeah, Rick is great. I've learned so much from him, and he's been really great for helping to help me get up to speed, especially when I joined Oxide, learning how to, as we think about how to do a design for things like the root of trust, just because I had some background, but I think Rick really had a lot more of like hands-on experience and everything. So I was excited to get the chance to really think about this problem from the ground up and design it. So this gets into what exactly we were looking at for when it came time to select a hardware, because it turns out that one of the things we were trying to figure out is that, okay, if we're going to build this system from the ground up, we actually have to select the processor to be able to be the root of trust. And there's a wide variety of processors out there. And so we did a pretty wide survey to try and figure out what would be out there. And we did a survey, and we eventually figured out was that the LPC55 S69 from NXP was the one that best met what we were looking for. It had features like a PUF, which is a hardware block that's designed that can, among other features, can do a secure identity and provides a secure boot mechanism, and had a lot of things we really liked in a processor to be able to build root of trust.
So, really quick, for root of trust, when you say that, is this just a processor that makes sure everything you're running is correct, or what's the actual role?
There can be a lot of different roles for what exactly we're trying to do. What I'm saying when I say a root of trust is this is a sort of backing up a few questions and thinking about the problem about how exactly do you know what software is running on the system, and exactly the idea about when we say trust, the idea is that if we think about building as a chain of links, we say, okay, if we can say we trust the software that's running on our root of trust, and we say, okay, if we trust what's running on the root of trust, then we can also say we trust what's running on, say, the service processor, and the service processor can trust what's running on the host processor. That's how we can say things that way. So the point is that if you're going to build up trust, you have to start from somewhere, and that's where the idea of the root of trust comes in.
Okay.
So we have to say, the point is that you have to start from somewhere and say, this is our point zero of trusting things.
Yeah, that makes sense.
Yeah. So we have our root of trust, and we selected the LP65S69. And then as we started out to try and work with this processor, it turned out that the hardware was pretty good, but actually trying to figure out how to make some things work was a little bit tricky, just because the documentation was sometimes pretty hard to figure out.
How so?
There was oftentimes just found to be kind of confusing or sometimes misleading, or we would see contradictory things, like the manual for the LBC55 had, was pretty long and described how to do things like, say, secure boot, but then the application note for the secure boot had very sometimes completely different things. So it was kind of left wondering exactly how do we make this work. At least what I picked up and was trying to work on. Mm-hmm. And part of trying to make this work oftentimes involved setting some settings that were persistent. And the idea is that you would write these to flash, and then the chip would come up and read this on every boot to try and figure out how to set various settings. And one of the tricky things about these settings is that it was possible to get these settings wrong so that the chip would no longer boot up at all anymore.
Oh, fun. Breaking.
Yeah, I feel like we should go back like one little bit, if only because I'm curious. I've never had to work with one of these, anything from this family, so I'm just kind of wondering, like, who's using this? Like, what products are using this?
That's kind of an interesting question, and I think if you look across, I think we can kind of make an educated guess based on what's available and what documentations are available. Mm-hmm. And I think the big thing you might think about actually is, say, this might be used in the automotive space, because in one of the other versions of this chip that's still in the same family of the LPC55, they have a CAN bus, which is fairly common in cars and other things like that. And some of the application notes also talk about things like, say, audio processing. So I think and also talk about, say, HDMI, and especially because this is supposed to be designed a secure, quote unquote, a secure processor, I think it's probably designed to be for things where you do want some level of security. So I could see automotive, or maybe secure audio processing that has like cryptography involved.
Like a set-top box.
Yeah, that's a good example.
Okay. So you've narrowed it down to this particular chip, and unsurprisingly, the documentation is not good. Even worse, contradictory.
Yeah, so I ended up bricking a bunch of chips while trying to make this work. And Rick, as we mentioned, was thankfully able to do some rework on a few of the boards, and actually gave me back a stack of the chips I bricked. So I have these sitting on my desk right now, and I need to figure out what I'm going to do with this stack of chips that I bricked.
I guess in my mind, when I think bricked, I think truly.
It could be
like,
coasters,
yeah,
for tiny drinks.
Yeah, tiny coasters. Maybe I'll put them in epoxy or something to be able to display them. But yeah, they're sitting right there, and the point is that these were mostly useless. And yeah. I mean, as amusing it is to keep doing that, it turned out that I didn't actually like to doing this to keep doing this because I wanted to actually make the chip work. So this kind of got into starting to think about how exactly we could try and make this solve this problem. And that was where the idea of taking a closer look at the ROM, which would ultimately lead to which ultimately read the settings would on the chip came up.
Mm-hmm, mm-hmm, mm-hmm. So how did you do that?
So this is where I give credit to another one of our colleagues. Cliff had sort of started or came up with the idea about taking a look at that. He had initially kind of taken a peek to try and do things, and then I picked up a Ghidra project from him, and so I started to learn how to use Ghidra for the first time.
Mm-hmm, mm-hmm. Any impressions?
I'd say Ghidra was very nice. I say for first time, but my standards were actually previously just using objdump, just because for other projects, not like a full reverse engineering, but oftentimes for debugging, I had spent a lot of time staring at output using objdump and trying to connect the dots that way, connecting assembly back to actual source code.
Now, when you were doing that, was that mostly because you were doing kernel work, like Linux kernel work?
It
Okay.
was.
That's what it sounded like. I never meet anybody who uses maybe Alvaro does, or maybe he's gonna totally contradict me, but like I never used objdump except in the context of a lot of people who recommend it, and they're always like kernel centric people.
I use it for embedded, mostly during the build phase, where I'll use objdump to dump the assembly or the list file kind of thing, just so I can look at that. But I haven't used it a ton otherwise.
Yeah, I mean, and part of my story of using objdump was back at a previous position. We'd oftentimes get just a binary and the corresponding small snippet of text output to try to connect the dots that way. And there wasn't a nicer way to be able to do that. So
yeah. So okay, so your process, you Ghidra it up.
Yeah, Ghidra, and I think it was really interesting just to try and figure out how this worked for the first time. I mean, Ghidra does for me especially, I found it did a great job about comparing the source disassembly with the actual assembly, and then trying to take a look at that. And then I kind of took a fairly haphazard approach in trying to piece this together. I think just because this was my first time in looking at this, it took me a bit to figure out. I'd say starting from the figuring out how to do the first boot up from the ROM in terms of figuring out how to trace a boot up of one of these microcontrollers.
Mm-hmm. So which image are you looking at in Ghidra? Is this like something you download from the vendor's website, or?
This is something you can pull off the ROM in terms of just being able to read it out. So
okay.
The ROM is something that's vendor specific for each different type of chip and even across different types of chips. And some vendors will make it such that you can't actually read out the ROM. But especially for this particular set of chips with NXP, you could read it out with the same set of debug tools that you might use to read out your flash or your RAM. So I was just able to save that out as a binary and then load that up, which made it really nice to be able to analyze.
So didn't have to like remove like the black plastic from it. Didn't have to like use a SEM. Didn't have to do anything terribly fancy. It was truly like a ROM dump.
Read memory address. Boom.
It really was. And I mean, I'd love to learn in the future how to do some of those more complex things to be able to read out ROMs. But for this particular one, it was pretty easy just to grab it.
Yeah. I think a lot of us like always want it to be cooler than like more work, more effort. But
if it's easy, might as well.
Yeah, I know. Yeah.
Okay, so you're looking at the ROM just to see what it does, because nobody will tell you what exactly it's doing.
Yeah, I mean, mostly because I really just want to confirm for myself and really have a high confidence in terms of what this thing is doing. Because that's the other thing when we think about what the root of trust is that if we can't actually say for certain we know exactly what this chip is doing, the concern is that if you have a malicious actor might come in and might try and change what this is doing to be able to break the entire chain of trust. So I think it was also kind of in our interest to really take a good hard look about what exactly this thing was doing. So I spent a long time, I think, trying to review, mostly focusing on from the ground up what this thing was doing from power on. And I really got a chance to try and figure out what this entire thing was doing. I think was being able to identify, I'd say, bits and pieces. And I think a lot of what I learned how to do is Gitter did a great job of, I think, cross-referencing addresses
Mhm.
to everything there. And I was able to use that against the LPC 55 user manual to say, okay, this function is referencing, say, the GPIO block. This function is referencing the power management block. And I was able to figure out things that way, what exactly certain functions were doing.
Did you use the tool to load the SVD files and then automatically map all the registers?
Yeah, that's what I was going to ask. Like, how much customization did you do?
Oh, I didn't do anything that's smart. I mean, I think I
Oh,
didn't actually know exactly that was a feature to be able to do. And I think this is the real thing, is that I've learned a lot about how to use Ghidra. So if I ever choose to do another project, I will probably be a lot smarter about how I do some of this access, as opposed to me trying to do things manually.
Mm-hmm. Another thing that often comes up when we talk with people who are using Ghidra, were you using it on a virtual machine or were you just using it directly?
I was using it directly on my
Yeah.
machine.
Jen doesn't trust the
I don't.
NSA.
I don't like. I'm like, at some point, I'm sure I'll use it. Like, right,
It's
right there.
it just turned 3 years old. I
I
saw.
know.
Yeah.
Yeah, I use it directly on my machine just because that was what I was doing. But I think with the I mean, it's always a little disconcerting when you talk about, log4j vulnerability updated in Ghidra, which is like, a great thing to
What
worry
else is
about when you.
new? Yeah.
Yeah, yeah. Maybe we should put the maybe we should put an article on that explaining that in the notes. Anyway, okay, we're moving on. We're moving on. Okay. Was there anything else that you used, like, once you kind of understood, like, once the root of trust had your trust, what did you what did you go ahead, and do next?
I mean, so I think thinking about what exactly the root of trust, and as you mentioned, trying to Ghidra has a way to be able to match up everything. But I think even if I had used it, I think one of the things that probably would have been kind of shocking was that there were still would have been some things that were incomplete in terms of the accessing undocumented registers, and that was really also what was kind of disturbing, is that trying to figure out what some of these registers actually did. And this is where we kind of get to the starting into the meat of the DEF CON presentation about
Mhm.
discovering there was an entire hardware block that was being accessed but wasn't really documented in the manual at all.
So why don't you tell us a little bit more about that block?
Yeah, so I think again that this is figuring out exactly what this hardware block actually did. I think this goes back to trying to figure out what this documentation was actually doing, and it wasn't actually documented in the manual. But one thing is that we did manage to find was that there was an Excel spreadsheet attached to a PDF that had a little bit more documentation. I think in particular of NXPs persistent area. The NXP's area was designed to hold settings like for various power settings. A lot of chips will oftentimes have tuning parameters for things like the regulators and other things like that that are very chip specific and can also be tuned.
Yeah. So how do you put an Excel spreadsheet in a PDF, and how do you get it out?
There's
What?
literally an attach function. I've never really figured out how to make one of these PDFs, but I mean, as far as I could tell, it was literally just attached to the PDF you opened in there, and I downloaded it. And scrolling through this, we were able to see that there were some fields that had this field in the persistent area labeled ROM patch, which was pretty interesting considering that the idea of the ROM being able to be patched was not mentioned anywhere. And again, when we think about to a root of trust, one of the things is that we assume about the ROM is that ROM is actually read-only memory. And the idea that you could potentially change the ROM, throws a whole wrench to assuming that we've got the trust of the root of trust.
Does that mean that it's operating more like Flash, or is it like it's odd for whatever reason it's copied into user available RAM and that's where you can change it? Like, do you have more details on that?
Yeah, so I think it's also worth first thinking about exactly why you would want to change the ROM. Just because, I mean, of course, we like the idea about being able to never have a ROM that's to be changed. But of course, ultimately, the ROM is just running code, and Unfortunately, code can be buggy, and sometimes you may need to fix bugs there. Or even a more practical thing is that I mentioned parts of the ROM can have settings like, say, for the voltage regulators. Figuring out the proper settings for voltage regulators may not actually come until after part of the chip is actually made. So there can be good reasons why you might want to change the ROM later.
Mm-hmm.
And I don't think it actually changes the ROM though, right? It's just like it intercepts the instruction. Like if you put a patch on address 3, whenever the PC gets to 3, it'll call the patch instead, or
That's correct. So at least for NXP's ROM patch, it offered two main features. One was the form that you mentioned, is that for the ROM region specifically, it would substitute a word at a particular address. So the idea is that you would write to a register in the ROM patch hardware, and it would swap that out for whatever you want. And the other setting it had was actually to insert an SVC instruction. So typically what you use for an SVC instruction is to have an unprivileged call into privilege mode, for example, to be able to do a system call. But what NXP did to be able to substitute this up is that because a ROM doesn't really have separation of privilege levels, they were able to use this as a way to insert something like an interrupt. So the idea is that the SVC handler would instead call a specific set of functions to be patched up based on what system call number you would use.
Yeah.
so that you kind of bypass all the safety features that way, I guess.
I mean, it's a designated way to be able to change the code flow, I'd say. It's an intended way to be able to change the code flow as opposed to an unexpected way.
Well, unexpected to the user, perhaps, because you didn't know it was there.
Yeah.
This was just a very formal way of saying that. Designated. Okay. Oh man, I don't even know where to go from here. Like, I guess.
So yeah, you found the spreadsheet, and then in the spreadsheet, you basically got the keys to the kingdom. Like, this is how you do the thing.
Yeah, I mean, the real trick, I think, was showing that this region actually existed. So I could have then take the fact where this memory of region was being accessed to the ROM and correspond it to this hardware block that was being accessed, just because I was able to tell, because of how the I/O settings were on this, that this was certainly a hardware block that was being accessed, and that I was able to tell to guess based on the code flow what it was doing, how exactly the ROM patcher worked, just because what was in the flash that NXP had was just the settings for the ROM patcher, and then it was sort of up to me to figure out exactly how to make sense of what that ROM patcher actually did.
And I do want to point out that on the presentation, your DEF CON presentation on the video, you show the very advanced hacking techniques to discover the hidden registers in these spreadsheets.
Yes, pressing the reveal button.
They basically just hit the rows, right?
Yeah, it's not clear to me how much NXP actually intended for this information to go out, and I think, unfortunately, in newer versions they got rid of this, which is kind of a shame, just because I do think this is information that should be available to the customer, just because I think ultimately it's important that you do know that it is possible to be able to patch the ROM, just if there are bugs.
Because there's no way to lock that, is there?
No, and this is part of what we actually found when we were trying to talk to NXP about this. We explicitly asked, just because I think if it had actually been possible to lock out the ROM, this probably would have been, a surprise, but probably not DEF CON worthy. And then I think where we got into had some fun was when we turned out that once I figured out how to actually program the ROM patcher, I started thinking about the implications. And I think I remember coming up with a short proof of concept that was showing exactly what I could do. And I think I remember showing people, says, "Hey, look at this! I can manage to read out a secure register with this, or I can read out an unprivileged register, a privileged register from unprivileged space from with this using this ROM patcher."
Mm-hmm. What was NXP's reception of this,
if any?
So I think I think overall NXP wasn't quite thinking like an attacker might in terms of thinking about this issue. I think especially again, I give a lot of credit to my colleague Rick and a lot of my other Oxide colleagues for really thinking about what kind of things you could actually do with something like this. And I think initially when we presented this issue to NXP, I think they were a little bit, we were initially only focusing on the privileged, unprivileged boundary. Mm-hmm. And they were initially, I think the response was initially, okay, you could do something with this, but there are lots of other ways to be able to do this. So, you should just be able to block this off, and it's not that bad. And then I think what of course we of course thought this was a lot worse, and I think it was really getting back to thinking about the approach that I think we ended up focusing to get NXP's attention was on the secure non-secure boundary.
Mm-hmm.
And so one of the reasons we initially wanted the LP65 was because it had a feature called Trust Zone, which is introduces the concept of a secure world, and this is also Trust Zone M. Trust Zone was a technology that was available on ARM's larger chips, the A series that have a full MMU. While we were working on chips with the microcontroller series.
Mm-hmm.
That uses a simpler version of Trust Zone. So the idea is that by focusing on the secure, non-secure boundary, we were able to demonstrate to NXP. We had a lot of fun trying to make that work.
Yeah, I mean, my familiarity with Trust Zone on the A series, it just felt very complicated, and thank God, not Broadcom. What's the other one?
Samsung?
No. What's the one the one that makes all the cell phones?
Qualcomm?
Qualcomm.
Yeah.
Thank you. Kind of comes in and magically takes care of all of it for you, so you don't have to worry your pretty little head about it.
So one of my previous positions was actually at Qualcomm. So it's really funny to say you don't have to worry about it just because I ended up having some interaction with trying to see Trust Zone there. And I think Trust Zone, as you noted, is it's kind of a complicated technology. I have some memories there about trying to make things work there on the A series processors, mostly for things like having caching between secure and non-secure world was a big headache for trying to make things work there, which resulted in some really hard to debug problems between things there.
So in summary, the Trust Zone lets you have a piece of code that's secure or memory that the other code you're running can't access, right? Is that the main?
That's a good way of putting it. It's helpful to think about the secure, non-secure as sort of another access, like privilege, non-privilege, and what you end up with is you end up with 4 different quadrants, each with a privilege level and a secure level, and you can have completely separate things there.
Cool.
Oh, I thought it was also able to detect if there was if some part of the image was also tampered with.
It really depends on what's implemented in Trust Zone. Trust Zone ultimately is just another processor mode, kind of like secure versus non-secure. And I think adding any sort of other detection or things like that is ultimately up to the implementer.
Okay, that's good to know.
And so I guess the problem is that you could bypass this with this ROM patcher.
Yeah. So again, this is where my colleague Rick came up with the idea about figuring out how to get something that NXP would really care about. So there's an open source project called Trusted Firmware App, which is designed to be a reference implementation for something to go into Trust Zone. And Rick came up with the idea about trying to use that as the basis for demonstrating that we could actually do something pretty there. The idea is that we'd be able to write an application in the non-secure world and be able to show that using that plus the ROM patcher, we were able to extract data from the secure world. Because part of the idea with Trust Zone is that you could potentially have things be completely separate, developed by separate teams. So the Trust Zone team is completely separate and has minimal contact with the non-secure team.
Yeah, which you don't want. You don't want that to happen in your root of trust, because it's going to validate everything else.
Yeah. But yeah, so we had a lot of fun trying to make that work. In particular, we got to do some fun. I think we call it a code golfing exercise in terms of figuring out how many small instructions you can do this. Just because the trick with the ROM patchers is that it can replace has a total of I think only up to 16 instructions and 16 items you can actually be able to change, which sounds like a lot, but if you're talking about trying to figure out how to do a longer sequence to actually do something useful besides just change one word, then we had to do some clever work between all of us. And so I think we sort of ended up being Oxide a challenge to be able to figure out, okay, who can come with an interesting sequence to be able to make the sequence smaller.
So then you had the example application for trusted firmware, and then you put your own user code in it and broke it basically.
We were able to show that we were able to take off the shelf trusted firmware secure world and using our own supposed to be somewhat less trusted, not unsecure world, we were able to read out data from the secure world, and I think that ended up getting NXP's attention.
Oh, good. Yeah, I was gonna ask, like, did they actually care this
And then they're
time?
like, "Hmm."
Don't do
So
that.
I'm curious that so were you guys just doing virtual meetings for this? Like the kind of just explaining some of this or showing them is kind of difficult, I would imagine, remotely. Or was it
To NXP.
pretty? Yeah.
Yeah, everything was remote, and I think we eventually tried to show them, send them emailing them proofs of concept. I think at a
Mhm.
point we had, I think, a couple of calls with them, but I think most of the work was just done offline and be able to send them says, okay, here's our code, and let people on the NXP side be able to analyze it.
Yeah. Okay. Yeah, 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 yeah. I'm just kind of curious. I'm like, how fast did they get back to you?
Uh, so they were. I think this is part of where I think Oxide ended up kind of frustrated by the experiences. Is that we reported this, and it felt like they didn't take it us seriously until we actually put in the effort to demonstrate them that says no, you can actually break some serious assumptions with this. And then they ended up saying, okay, we're going to need 45 more days on our embargo to try and make this work. And I think this is part of I think as we were reflected on this, we would have really liked NXP to do their own analysis, and again, thinking like perhaps an attacker or someone else to be able to say, hey, what is the extent that we can actually do things with this vulnerability? Is it really that simple as, oh yeah, maybe you can, maybe it's just an interesting feature, or can you actually break some things?
Especially when you're selling a secure processor, right? Like maybe in a generic
Yeah.
microcontroller, like whatever. But
Yeah,
I think the thing, at least what it's sounding like to me, is that the company's basically putting the onus back on you to prove this, which your company is not. There's no. It doesn't seem like there's a whole lot of benefit for you guys to put in this level of research because the company not isn't necessarily that's not their main mission. I'm perfectly.
no, and I mean, I would say everyone at Oxide was very supportive. I mean, the CTO Brian Cantrell, he thought this was really cool to be able to find and do everything, and I mean, he certainly supported us trying to pursue this, especially into things like doing the DEF CON talk. But at the same time, there was kind of this undercurrent of this isn't actually helping us get to an actual finished product, because it
Yeah.
turns out a lot of customers will think this might be cool, but yeah, it turns out you can't actually sell a DEF CON talk to customers. So
and so in the end, did they fix anything or?
what they ended up doing was giving a potential what I consider an acceptable mitigation is that part of what as part of NXP's security settings is that they had a way to be able to restrict access to all the hardware blocks based on setting bits, and it turned out they always had bits to be able to change settings for the ROM patch to be able to say, okay, only the secure world can access this, only the non-secure world can access this. Those were always there, but they just weren't documented. So what NXP ended up doing was they updated the manual to say, oh yeah, just set this bit to be able to prevent for proper security settings, but they didn't actually say what this bit was corresponding to. So I think this was another thing is that we got NXP to actually tell people that they should be setting this bit, but they didn't really do as much great of a job as we would like about actually explaining fully what the problem was.
And from what I understood in the presentation, they didn't go out and like tell the world, right?
This is another thing that we found pretty frustrating was the lack of transparency about who exactly they were telling them this issue about. I mean, we couldn't find anything on their website saying, "Hey, there's this issue. We should try and do that." So I think it was through NXP's internal channels, which is another thing to think about. That especially if say you're a small vendor who decides they want to do this for their product and they're not in contact with NXP, how exactly would you know about this issue?
Yeah. Like you wouldn't, Oxide wouldn't have heard about it if you hadn't discovered it.
Yeah.
Probably not. I mean, maybe one of the FAA we were in contact with might have actually gotten us access, but again, this is sort of we would have happened to be lucky. I mean, if you were to just go to DigiKey or Mouser or buy however many of these chips you needed, you probably would never have known about it.
I guess I'm kind of, going back to originally what kind of kicked this off was that you were doing an evaluation of processors to use for this. You settled upon this particular device. Do you have any, I don't want to say regrets, but do you Do you kind of like wonder like why was this like the one that best fit, and do you feel like there's kind of like an issue overall with what chips are available for these for the type of application that you were looking at?
Yeah, this is something we've thought a lot about what exactly it means to select something, and I think in particular because we're trying to build something new from the ground up,
Hmm.
um, it's hard to try and find something that's off the shelf. And I think trying to choose an off the shelf microcontroller that doesn't quite have all the features we want. I think sometimes it feels like part of Oxide, what we're trying to do is convince people that of the value of transparency and the idea about saying, hey, maybe you should, not have undocumented features in your ROM. I mean, and also one of the things we also wanted to be able to do was potentially like get access to be able to audit the ROM source code to be able to see what else was in there, and NXP told us no.
Hmm.
And I can understand from a traditional business perspective that you want to keep some things confidential, but for what we're really thinking of for security, that kind of comes into conflict with that. The idea about more
Hmm.
transparency is good because, again, as noted, technically Oxide and everyone is professional security researchers. There are a lot of people who have like experience with it, but it's not like we're spending, you know, 50 hours a week just trying to break chips.
Yeah.
And I'm certain is that people out there who are doing that out there.
Hmm. Hmm. Yeah, it just doesn't sound like there's like a closed loop between security researchers with technical marketers from chip vendors.
Yeah, and I think especially as you pointed about technical marketing, I think trying to explain to customers when they're evaluating a chip why exactly they would want more transparency. Because I think if you have, say, one of these big manufacturers that's going to buy millions of these chips, if they put pressure on
Yeah.
NXP, say, to be able to do that, they might be able to have the get them to consider changing what
Yeah,
they're doing.
And in that case, they might just show it to them only. And
yeah.
yeah.
But volume-wise, I mean, the truth of the matter is, like, as far as, like, if you're talking about some of these high volume manufacturers, it's because they're working on a consumer product and there's not necessarily like, they're just working so fast to get it out there into the world that they're not necessarily even considering a lot of those aspects.
Yeah, I think that's very true, especially when you think about consumer products. I think that have a very short life cycle. About you're kind of expected to replace them every like 3 years, and that's kind of unfortunate from both a longevity perspective and everything. But and especially because I've seen articles before that point out, especially the tradition about handing off older devices. Say if you have a cell phone, handing that off to someone else. If you're a parent, you have a kid, you hand it off to your teen. Your teen is potentially using a less secure device now that maybe isn't getting software updates or other things like that. And that's a great vector to be able to introduce vulnerabilities that way too.
And maybe using it in more riskier ways than than the parent potentially. I don't know.
Yeah,
I
perhaps.
guess I'm applying like a lot of assumptions there.
So you had to learn, Ghidra and various tools to get this done. What other tools did you use, and how did you, go about learning? What resources did you use to learn these new tools?
Yeah, Gitter was the big one I learned how to use, and I think mostly it was just a lot of playing around with the interface, and I think also uh, discovering things on there. I mean, and I think also a lot of what I ended up doing was a lot of poring over the ARM manuals as well to be able to review how the assembly worked. I certainly had some background to be able to read ARM thumb assembly, but some of the weirder intricacies I needed to go back and review the documentation. Just a lot of poring over documentation to be able to read there, and a lot of trial and error.
Mhm.
And also, I think I continue to learn new things about Geeter and potential features. I think I was very excited when I discovered there was a Geeter feature to be able to help handle inline functions better, be able to set custom register
Oh,
allocation as well.
Mhm.
yeah. Inline functions would be a nightmare because they'd just be redefined everywhere, or well, not even defined, right? Just inline. Yeah, hadn't thought
Yeah.
about that.
A lot of repeat code
Yes.
kind of gets cleaned up there. Yeah. Well, let's kind of turn our heads to a slightly different topic. You mentioned earlier that you came from the Linux kernel development world. Tell us a little bit more about, what is that world like? What was your experience in it?
Yeah. So my first job professionally ended up being working on kernel development for Android phones. So that I happened to be hired at a time when Android was just beginning to take off, and they needed to do hire a lot of people to be able to do Android development. So I got to do a lot of experience there, and that was really got my first taste of kernel development, and I got to learn a lot, especially about Android specific things. And I ended up sort of focusing on memory management just because there were some Android specific bits that hadn't really been finished there, and I got a chance to do that. A lot of my role initially was mostly internal facing. I didn't have was not as much emphasis about trying to do stuff in the community, but I think I kind of wanted to push to be able to get a chance to really do that work out in the community, just because that was always the pitch about being able to contribute to open source, really get a community experience.
Yeah, there's definitely seems to be like professionally, people want to hire people who've already contributed, thank you, to the community, but then you don't necessarily, once they're in a company, you don't necessarily see them oftentimes contributing back. It's kind of like they've been captured by they've been drafted and now they're off the market.
Yeah, and I think especially some of my previous roles, there was a pretty big divergence between people who were, I'd say, focused on like shipping a product and people who were more focused on the community work. And I think in an ideal world, you'd have a lot more overlap between those two. Is that because ultimately part of the reason companies want to participate in the community is because so they can ship a product. I mean, it's not necessarily, companies are not altruistic unlike individuals who can sort of have this
really
nice. Yes, I know, it's shocking.
Huh? I had never heard that. Alvaro, did you know about this?
Nope.
You heard it here first.
Companies aren't in it for the money, huh? Sorry.
But yeah, but I eventually did get a chance to do some more community work, and I think I was really grateful that I was able to have I think fairly positive experience when I did contribute in the community. Especially because I think I was focusing on a fairly narrow area. A lot of times, both the Linux ARM kernel community and also the memory management communities. I think especially what people sometimes miss about is that when you say the Linux kernel, is that the Linux kernel is actually like a huge number of smaller sub communities that all have their own areas to get through. Everything eventually goes up to Linux, but ultimately most of your actual work will probably be much more with the specific communities you work with.
Like talk a little bit about like the individual communities that you're saying. I would assume that there's probably a video driver. There's probably the audio driver portion.
Yeah, I mean, each architecture has their own community. Like x86 will, ARM will. These days, RISC-V has a growing community there.
MIPS had one.
Oh, MIPS
for a very long time.
Yes, MIPS is still there, kind of, but
yeah, but most of that company moved to ARM when they had the chance.
Yeah,
if we're honest.
But there's a graphics community which also includes a lot of stuff, and I think you also see overlap between the communities, just because especially like graphics, you'll have a lot of the traditional stuff, like say for your desktop, you'll have desktop graphic development, but then you also have some overlap with say the ARM community in terms of ARM graphics drivers. And you have USB, and then I think a lot of the file systems as well have their own things, and you'll certain subsystems will have more overlap with each other. Like it turns out that memory management, file system, and storage have a lot more in common than say, file systems and x86 maintainers. It's not to say they will never have any interaction, but you'll sort of see pockets that will end up overlap. And there's been a lot of really great work in terms of studying about how exactly the Linux kernel communicates.
What do you mean?
Like which developers end up talking to which others developers, and you'll be able to trace through how that actually works. Someone did a PhD thesis about this, or at least part of some research presented at a past conference about how exactly Linux kernel communicates, especially because everything is completely distributed. I mean, for the most part, everything is just done over email and sent back and forth all over the globe.
So I'm just imagining now. Do you guys remember network diagrams that you would occasionally see? You'd someone would analyze your Twitter account or your Facebook account, and you just get these graphs.
I'll have to find the PhD for the show notes like that.
Yeah. I feel bad. I'm drawing a blank on who exactly did that, but I'll have to dig that up so you can put that in there, because it's fascinating to watch about how exactly people communicate and who's actually doing the most work. And I think it ends up sort of being a long tail about you have some people who are sending a few emails, but then you have a lot of people who are sending a lot of emails and talking to a lot of people.
Mm-hmm.
And,
Mm-hmm.
and this is all, it's email, but it's mailing lists that are public, right? So it's easily to analyze, easy analyzable.
Yes.
The source research is there.
Yes. Everything is there and out in the open, which
Yeah.
has its pluses and minuses.
I mean, as we've seen, as people have pulled up, Linus's emails and like that have not aged well.
Yeah, and I think this is what I think a lot of people I think have had a chance to learn is that I think there's a big difference in how you communicate. Say if you're communicating with your small group of friends versus how you're communicating in a wider context. And I think this is something I think especially with the so I'm not going to say surprising rise of Linux, but I mean like Linux has been successful beyond a lot of people's wildest dreams, and I think a lot of people figuring out that maybe they have to communicate slightly different now that Linux has, a lot more eyes on it.
Yeah, I mean, a bigger
Yeah.
community.
Yeah.
Yeah. I don't know if that memo actually got to everybody. I'm just saying.
I mean, it's a big community, right?
Yeah, that's the other thing is that I think about Linux as being like a big community. Like if you look at a huge mega corporation, you're going to have lots of different people in there, and there are going to be people you really enjoy working with, and maybe people you don't enjoy working with. And I think that's true for the Linux kernel community. And I mean, I'm also just going to say people who haven't got the memo that they need to be communicating better absolutely really need to get on board and say that like it's important to be respectful and figure out how to build the best community possible.
I think that kind of goes back to a lot of the reason why I can speak for myself. A lot of the reason why we started out in engineering is because we didn't really want to deal with anybody.
Yeah,
We're just like, it's about the machines and about this, and then like I think Linux developers in particular are a more distilled version of that.
Yeah, it's kind of funny to hear that because I think a lot of people will say that it's only about the code, but that's very funny if you've actually worked in Linux kernel development, just because so much of it actually is about trying to figure out how to get things merged. Just because it turns out trying to convince a maintainer about why exactly you should do this approach actually takes an awful lot of human interaction, and I think that sometimes gets over on there. So I think you sort of have the you end up needing to find a lot of people who it turns out are very good about actually caring about how the other person goes and is doing, and also are interested in doing this type of work.
Yeah.
That's pretty good to hear.
That's reassuring. That the community has kind of at least changed, morphed over time.
There are I think a lot of people who I think have done who are trying to build a better community, and I mean I think ultimately that this kind of comes down into every organization, I'm using that in the broadest sense here, has a culture, whether you say you have one or not. And I think there have been a lot of people who realize they need to put in the effort to figure out and answer what kind of culture actually they want to work. And I mean, I'm not going to claim that everything is absolutely 100% perfect, but I think there are a lot of people who have done a lot of reflection and try to figure out what exactly they want to see. And I mean, I think there's certainly promise for people who want to be able to build that better community, and it's absolutely not an easy task. But
but I also kind of wonder if there are some areas, some types of people gravitate towards some areas like graphics or audio, things that are very visible, that like seem to have very direct impact, like kind of a dazzling impact in some people's eyes, and they gravitate towards that area versus, let's say, more mundane areas that are still very important to Linux running. Yeah. So there's memory management.
Just making stuff up.
I mean, it kind of depends about what, and I think, especially when I was at a previous role when I was a Fedora kernel maintainer, people often would ask me like, "Hey, I think kernel development is kind of cool. How do I get into it?" And I think what I would end up telling people is that you got to figure out exactly what motivates you in particular, because there's so many things you can actually do in the kernel and so many different things. Because as you noted, like maybe your idea is that you want to try and get your graphics driver better. Maybe you actually really like performance analysis, and I am not a performance analysis person. So like anyone who wants to try and do that, I say more power to you and try and make things run faster. I mean, and so I think there's so many different things, and especially as everyone's like favorite buzzword DevOps, Kubernetes, a lot of that is based in containers and features in the kernel. And if you want to learn more about that, that's a great place to start to be able to figure out how these things work and how you might be able to build on top of that.
2 comments here. First of all, I don't think that you can say those cluster of words without throwing up, like, a random GIF, like a meme or something, and secondly, we do have an episode, we will link to it,
About
about
Kubernetes and
Kubernetes.
all sorts of things. Yeah.
Yeah, which is full of memes. Like, just the show notes is
Yeah,
just
the
full
show
of
notes are
memes.
the flashiest ones
Yeah, it's a pity I can't link memes right up here
on audio.
on audio. Yeah, I don't know. Do you have any good reverse engineering memes?
Oh, that's a good question. I'm sure there are a bunch, but
I
we're
think
gonna
we
have
need
to
to start a
request
thread
them.
on this.
Yeah.
I agree.
All right, and folks in the Slack channel, not Slack channel, Discord.
What
Cut
did we
that out.
suddenly so first of all, I did start a Slack channel, but we've never done anything with it. We ended up going with Discord, Alvaro.
Oh, good. So I'm not completely wrong.
You're not technically wrong, but like many things that we've set up, we only check it once every 4 or 5 years. And I finally checked it because the Mountain View reverse engineering Slack channel has now, ceased.
And it moved to Discord.
Yes, it all moved to Discord. Okay, so so back to everything. So is it pretty much safe to say that kernel code is still only written in C? Has it evolved? Has it moved past that?
So it's still definitely C, but I think it's also important to think about exactly how the C language has changed, and I think it's certainly not the same C code base and everything. And I think part of what some of the stuff I worked on related to the Linux kernel before was things related to some security. I think security hardening. So the idea is to be able to work with those people to help eliminate entire classes of bugs. And I think part of what has made this possible has been in tooling around improvements of tooling around things like the compiler. GCC, for example, has come a long way to be able to do features there. So I think it's still certainly the C language with all of its authority things. You can still definitely write buffer overflows in C, but there are perhaps more ways and features to be able to detect these things and be able to figure out how to do that systematically. And I think even just trying to figure out how to use newer C standards. I think there was an article that came out recently that was talking about moving Linux kernel to
C99.
C99, which is huge step forward.
I'm just like, really, we're still not even there.
So my understanding, not going straight to C11 or later, it's just Linux still supports some older GCCs that don't support C11.
Yeah, and it's really having done some of this before is that figuring out how to update your tool chain is kind of tricky, just because there's so much code out there, and especially if we think about because Linux has been used so much in embedded development, trying to update embedded tool changes is jumping through an awful lot of hoops to be able to support these devices. We talked about before is that supporting these things is that getting vendors to be able to talk about what they support and actually do an update is sometimes an uphill battle.
Yeah.
But people love to say Microsoft has like the backwards compatibility stuff down, right? But Linux, like we were saying, it uses some old GCC, but I think you can find any architecture processor in Linux, the kernel still run on it, which I find amazing.
You can find an awful lot of obscure architectures there, and I think especially in the Linux kernel, I think the rules is that if you're willing to maintain it for the most part and actually make sure you're fixing things up, you can have it in there.
Yeah. I guess one of the questions I have is, for you guys, do you guys have a particular procedure that you use when you are updating your build tools?
Do you mean at Oxide or in the kernel?
Just in general, like on any project that you've done. If you're going ahead and like updating your build tools for a particular code base, what are the steps and best practices that you're using?
So I think this is a lot of time is also answered by what is your testing strategy in general? Because from my experience, is that a lot of the issues with trying to upgrade tool chains or other things like that shows up pretty fast. Like it's oftentimes, I should back it up a little bit. It's either going to be fail very fast, as in doesn't work at all, or it's going to be an incredibly obscure bug. which I think kind of ends up going to, again, how good is your testing in general in
Yep.
terms of
Yep. Yeah.
catching all that.
Yeah, it's just it's funny. It's like a lot of the times on projects I've been on when we change build tools, a lot of it is like, can you go through all of the tests, go through all your test coverage, and everything's worked out okay? And what exactly is the size delta of the image itself? Just because a lot of the things that I work on are like bytes actually count
Yeah.
significantly for
Yes.
me. Byte, not tens of bytes, not hundreds of bytes, bytes.
Yeah, I think another thing is always, especially with upgrading C compilers, you often get new warnings because, again, as we talk about trying to make C better, part of it is that we figured out how to be able to refine things, to be able to say warn that things so that,
Hmm.
okay, maybe you shouldn't be doing this, or maybe you shouldn't be doing, you should be checking this. And I think part of
Hmm.
it is figuring out is that are these warnings you actually need to fix now, or as it turns out, sometimes one of the things that if you upgrade compilers, especially in the kernel, that you can get an entirely new set of warnings. And sometimes it's just too verbose to be able to have on at the moment. And so it'll take that on as a project to eventually be able to
Yep.
turn them on.
Yep, yep, yep. Agreed. Absolutely agreed. Occasionally, so in general, our audience ranges wildly in terms of like what they do. We even have like mechanical reverse engineers
Oh,
that
that's
listen to
cool.
the class. So, so one of the things that's interesting is occasionally that pops up is that some people feel that C code is intimidating. Do you have any advice for people, trying to get more comfortable with C? Let's say maybe they're used to C++,
Or
maybe
Python.
they're or Python.
I mean, I think this sometimes comes down to trying to work with any language, and I think also practice and just being up to willing to do things. I think another thing is that I try and would always tell people, especially when I was a kernel maintainers, is that it's generally these days, modulo doing some very specific things. It's pretty hard to like completely destroy your machine. I know this is a bad example for what I've been doing here in terms of like I
Yeah.
have the stack of chips, but if you're doing like say on your generic desktop and trying to do things, make things work, generally if you do a kernel panic, it's probably not going to completely brick your machine. As long as you know exactly how to be able to get it back and be able to switch kernels, you can do exactly whatever you want. So I think it's important for people to remember is that C is pretty low level, but if you're trying things fairly carefully, you're not going to do damage to your scene. And then it's okay is that if you have things, worry things that way. And I think sometimes ultimately experimenting and
Yeah.
trying is the best way to try and move things forward. And I think also, especially using newer tool chains, they're going to provide a lot more warnings. And I think that's also can be pretty helpful is that if you're worried about trying to have a buffer overflow or be able to do things manually, they can try and help check things out, especially running
Hmm.
debuggers tools out there.
Absolutely.
When you mentioned kernel panics, when you develop, do you usually do it on the machine you're working on, or do you have a VM or a second machine?
Oh, that depends about what exactly I'm doing. Ideally, I would not be doing it on my same machine just because that's really hard to be able to debug. Especially that if I have a second machine or doing stuff in a VM, that's nice. QEMU has also come a long
Hmm.
way, and figuring out how to be able to get output and be able to access things
Hmm.
that way is also pretty nice.
Awesome.
And I guess one of the questions we like to ask everyone, and this can be independent of reverse engineering, but what's your favorite tool, or what are some of your favorite tools that maybe people might not know about or should know about?
Oh boy. Honestly, I think documentation I think is sometimes undersold as a tool in terms of just being able to read out there. I mean, sometimes the documentation is going to be confusing, but sometimes you're going to find a spreadsheet attached to a PDF. So I think you can just learn a lot from being able to read the documentation. And I think trying to figure out what's going on from there, I think is just a great way to be able to learn.
I
Awesome.
Yeah, I agree. Wow.
That's a new and unique answer.
Yes,
Shockingly.
that's good.
Elroad, any more questions?
I think we've covered all the questions we had on here. Yeah. I mean, we could keep talking about Linux, kernel, Rust, all these things for hours, but from what we had, I think we covered everything.
Yeah. So let's close out the show. Elro, do you want to handle that?
Sure. So, well, first of all, thank you so much for joining us. Where can people find you online if you want to be found?
I am on Twitter at OpenLabbit, LABBOTT, and love to read what's on Twitter, especially people who are doing reverse engineering type stuff. So
Awesome. You can find me, Alvaro, at Alvaro Prieto on Twitter, alvarop.com. Where can people find you, Jen?
You can always find me on Twitter at RebelBotJen.
We're unnamed underscore show on Twitter, unnamedre.com. Thank you so much for all our Patreon supporters. Come join us on Discord and hopefully see some reverse engineering memes coming up soon.
Wait. We have to go through all the names. It's been a while. It's been a long while.
Or is this list updated?
This list is updated.
All right. I'm just going to read some names. Raphael, David, Paul, Dan, Adrian, Gabrielle, Dale, Enzies, Marty. Oh, I haven't seen a lot of these. Arturo, Applied Science, of course. Thanks, Beth. Jacques, Rushard, Wyatt. I am butchering these. Bob, Akihiko, Jens, James Chambers, Mike, Max, William, Todd, Kevin, Keithy, Jeff, Ewan. Oh, this is more than I thought. I'm so sorry. Brian, Julian, Scott, Elliott, another James, Allison, Bren Dizzle, Roz, Zach, Lenore, and Gareth. I did not know we had so many Patreons. This is lovely.
Yeah, and we really adore them. And as always, please put your reviews using your podcast app, whether it's iTunes, Stitcher, Spotify, whatever you're using. Maybe it's Google Music. I have no idea. I have no idea what people use anymore. Reviews are always appreciated.
And yeah, again, thank you so much, Laura, for joining us.
thank you so much for having me. It's been, a lot of fun.
Wonderful. Till next time.
Wave the camera again.
I don't know why you're waving at the camera. This is going to be at the end after all the music dies down.